Hello, my name is Ahmed Umate. I will be presenting today on simple linear regression. So I'll start by going through the table of contents or the agenda I have today. So we'll start by the introduction of linear regression. We'll carry three tests today. The first regression test, the dependent variable will be depth, the independent variable will be income. And the second regression test, the dependent variable will be savings, the independent variable will be income. And finally, the third regression test, the dependent variable will be stocks and the independent variable will be savings. Then we'll follow by the takeaways and questions if you have any. So in order to start my presentation, we'll start with the introduction. So to introduce, in statistics, we use linear regression mainly as predictive analysis tools. So it shows the estimates. The regression estimates are used to explain the relationship between one dependent and one independent variable, as we have seen in the table of contents. So the three tests that we'll do will explain more about uh, the debt versus income, the savings versus income, and the stocks versus savings analysis for linear regression. So we'll start with the first test performed, which is the debt versus income analysis. So in the first hypothesis test, we have again our null hypothesis and our alternative hypothesis. So in the null hypothesis, the regression coefficient beta is between the debt and so the debt values and income values is 0. And in the alternative hypothesis, the regression coefficient between the debt and income is non-zero. So after performing the test and inputting our data on our PSPP software, the results were generated. So as a result, a simple linear regression was conducted to determine whether the observed debt values could be predicted from knowing the income. So based on the income that we have, is it possible to estimate the debt values or to predict the debt values? So based on the results collected, beta was 0.002, r squared, which is the coefficient of correlation, is 0.26, and the p-value is 0.535. So based on that, we had to conclude that there was no significant rejection which was found on this test. So after doing this test, a second test was made, which was the savings versus income analysis. In this test, we also had again the null hypothesis and the alternative hypothesis. In the null hypothesis, the regression coefficient beta was between savings and income is 0, and the alternative, the regression coefficient between savings and income is non-zero. So again, we've taken the data inputted in the software, and we carried a simple linear regression to determine whether the observed savings amount could be predicted knowing the income value. So based on the income we have, is it possible to predict the savings that we'll be making? Basically, the test we did. So a statistically significant regression emerged. Here beta was 0.101, so the regression coefficient was 0.101. The coefficient of correlation squared is 0.824, and the p-value was 0. So thus this test rejected the null hypothesis and predicted the saving income values. So the APS here is equal to 0.101 times SL minus the C, which is 203.5. So what we could say is APS is predicted to decrease as the SL increases. So with a 95% confidence level, it means that this doesn't contain a 0. Hence, hence this prediction has a lending support. The final test which we did was stocks versus savings analysis, the third hypothesis test. The null hypothesis here was the regression coefficient beta between stocks and savings is 0, and the alternative, the regression coefficient between stocks and savings is non-zero. So a simple linear regression was conducted to determine whether the observed stocks values could be predicted from knowing the saving values. Based on the data inputted in the software and the results generated, a statistically significant regression emerged. Beta here is equal to 0.164, r squared. Beta again was the regression coefficient, r squared will be the coefficient of correlation squared is equal to 0.081, and p is equal to 0. So thus we have rejected the null hypothesis and predicted savings and concluded we could predict saving from the stocks. And the values here, alpha is equal to 0.164 times SL minus 1007. APS is predicted to decrease as SL increases again, further at the 95% confidence zero, meaning that the zero, it does 95% confidence level doesn't contain zero, hence lending support to the prediction. So after doing this, we move forward to the takeaway. So what did I learn from this test? The first thing is that R squared is a statistical measure of how close the data are fitted into the regression line. The alternative hypothesis for this test for regression is that the regression coefficient is non-zero, and finally the null hypothesis is that the regression coefficient is 0. So any questions, please feel free to ask. I will be more than happy to answer you. Thanks again for watching my presentation. I will post the link, and if you have any questions, please feel free to ask, and I should be more than happy to help you. Thank you.